বলছে ড্রপস আর কামিং আউট আফটার এভরি 1 সেকেন্ড, মানে 1 সেকেন্ড গ্যাপে গেলে ড্রপটা আসছে। ওকে, সো ইউ আর asked to calculate the distance between the second drop and third drop after 5 seconds. So at t equals to 0, the first drop comes. এক নম্বর ড্রপটা যখন t equals to 0 তে আসে, সো 5 সেকেন্ডে কতটা এসেছে? এই t equals to যখন 5 সেকেন্ড, তখন এক নম্বর ড্রপটা এইখানে আসবে, ফার্স্ট ড্রপটা। বুঝা গেছে? তাহলে 5 সেকেন্ড ধরে ফার্স্ট ড্রপটা পড়েছে, 4 সেকেন্ড ধরে থার্ড ড্রপটা পড়েছে, ঠিক আছে? 3 সেকেন্ড ধরে সেকেন্ড ড্রপটা পড়েছে। হ্যাঁ, এটাকে জিজ্ঞেস করে সেকেন্ড ড্রপ আর থার্ড ড্রপের মধ্যে এইটুকু ডিস্টেন্স কোনটা? এইটুকু ডিস্টেন্স ট্রাভেল বাই দ্য সেকেন্ড ড্রপ, ব্যাস এইটু বললাম। এটা হচ্ছে কি ডিস্টেন্স ট্রাভেল বাই দ্য থার্ড ড্রপ, H3, ঠিক আছে? কিন্তু দে আর রিলিজ ফ্রম দ্য ট্যাপ, দ্যাট মিনস অল দ্য ড্রপস আর রিলিজ উইথ ইনিশিয়াল স্পিড 0। H2 কত লিখবো? H2 is the distance traveled by the third drop in 3 seconds. H2 হচ্ছে distance traveled by the second drop in 3 seconds. তাহলে লিখে দেবো কি হাফ GT স্কয়ার, এই ফর্মুলা, তাই তো? UT প্লাস হাফ GT স্কয়ার, U তো 0, তাহলে এখানে কত লিখে দেবো? হাফ G ইন্টু T, T কত? 3 আর 9, বুঝা গেছে? 9G বাই 2 মানে 4.5G হলো এটা। সিমিলারলি H3 কত? H3 হচ্ছে হাফ GT স্কয়ার, কিন্তু এখন টিটা কত? টিটা হচ্ছে এখানে 4, হাফ G ইন্টু মানে 16, মানে হচ্ছে 8G হলো, ঠিক আছে? এদের মধ্যে গ্যাপটা কোথায়? এই গ্যাপটা যদি জিজ্ঞেস করি 8G মাইনাস 4.5G, মানে এই গ্যাপটা ডেল্টাই যেটা 3.5G, এটা আনসার, মানে 35 মিটার। বুঝা গেল? বাস, এগুলো না পারার কি আছে? মাথা খাওয়াতে হবে, মাথা খাওয়াতে হবে। হ্যাঁ, আর কিছু? ফাইন্ড দ্য ভেলোসিটি অফ দ্য বল when it reaches the ground and also calculate the time. একটা বল ছিল যাকে নিচের দিকে ছোঁড়া হয়েছে 10 নিয়ে, এই নাম্বারটা ইউ নাম্বার, ঠিক আছে? তাহলে এবার আমি করি কি, যখন এই ধরনের প্রজেকশন অঙ্ক থাকবে আমাকে বলতে হবে যে কোথা থেকে ছাড়া হয়। আমি এই পয়েন্ট থেকে ছেড়েছি, এই পয়েন্ট থেকে আপওয়ার্ড থেকে পজিটিভ বলবো, ডাউনওয়ার্ডটা নেগেটিভ। আর আমি ভার্টিক্যাল মোশনে জি ইজ অলওয়েজ অ্যাক্টিং ডাউনওয়ার্ড, মানে জিটা নেগেটিভ হবে এখানে। তাহলে প্রথম জিজ্ঞেস করেছি যে কতক্ষণ টাইম লাগবে সেটাকে বের করি। তাহলে ফর্মুলা কি লাগাবো? এইচ ইকুয়ালস টু রুটি প্লাস হাফ জিটি স্কয়ার, এটা লাগাচ্ছি, ঠিক আছে? এবার উইথ সাইন দেবো, কিন্তু এইচটা কি? এইচটা হচ্ছে ডিসপ্লেসমেন্ট। ডিসপ্লেসমেন্টটা কোথা থেকে? এ থেকে বি, এটা -40 লিখবো তো? বোঝা গেল কেন মাইনাস লিখলাম? মাইনাসটা কেন লিখেছি বুঝতে পেরেছিস? আমি ওগুলো বন্ধ করে রাখ, সাইলেন্ট করে রাখ ফোনগুলো, ঠিক আছে? ইউটাও নেগেটিভ আছে, তাহলে -10t, জিটাও নেগেটিভ আছে, -5t স্কোয়ার, হয়ে গেল? তাহলে সব কটা একদিকে নিয়ে আয়, তাহলে 5t স্কোয়ার প্লাস 10t মাইনাস 40 ইকুয়াল টু 0, 5 দিয়ে ডিভাইড করে দে, t স্কোয়ার প্লাস 2t মাইনাস 8 ইকুয়াল টু 0, ঠিক আছে? t স্কোয়ার প্লাস 4t মাইনাস 2t মাইনাস 8 ইকুয়াল টু 0, t প্লাস 4 আর t মাইনাস 2 ইকুয়াল টু 0। t তো নেগেটিভ হতে পারে না, তাই t ইকুয়াল টু 2 সেকেন্ডের মধ্যে বলটা পড়ে গেছে। এবার ভেলোসিটি জিজ্ঞেস করতে বলেছে, তাহলে ভেলোসিটি ফর্মুলা কি লাগাবো? ভি ইকুয়াল টু কিউ প্লাস ভিটি ফর্মুলা লাগাবো, ঠিক আছে? ইউ কত? -10 রয়েছে, জি কত? -10 রয়েছে, টি কত? 2 পেয়েছি, তাহলে -30 মিটার পার সেকেন্ড। এই নিয়ে বলেছি নেগেটিভ কেন? পার্টিকুলার ভেলোসিটি নিচের দিকে আছে বলে। জানো দাদা রিটার্ডেশন কোথায় হচ্ছে? ধরি আপওয়ার্ডটা পজিটিভ, ডাউনওয়ার্ডটা নেগেটিভ, নিচের দিকে যাচ্ছে। হ্যাঁ, নিচের দিকে যাওয়ার সময় যদি দেখি যে ভেলোসিটি বেড়ে যাচ্ছে, তাহলে অ্যাক্সিলারেশন আছে। নিচের দিকে যাওয়ার সময় যদি দেখি যে ভেলোসিটি কমে যাচ্ছে, তাহলে বলবো রিটার্ডেশন আছে। এইভাবে বুঝতে পারবো। ইনিশিয়ালি পার্টিকুলার কত? 10 ছিল নিচের দিকে, ফাইনালি কত পেলাম? 30 পেলাম নিচের দিকে, তাহলে ভেলোসিটি বেড়েছে, তাহলে অ্যাক্সিলারেশন আছে, ঠিক আছে? নিচের দিকে যাচ্ছে মানে রিটার্ডেশন, এটা ভুল। উপরের দিকে যাচ্ছে মানে অ্যাক্সিলারেশন বা রিটার্ডেশন, এটাও ভুল। আমাকে দেখতে পেতে ভেলোসিটিটা বাড়ছে না কমছে, যদি বাড়ে তাহলে বলবো অ্যাক্সিলারেশন, যদি কমে তাহলে বলবো রিটার্ডেশন, এইভাবে দেখতে হবে। এই পার্টিকেল যদি ঘুরে যাও, হয়েছে? আর নেই তো, আজকের টপিকে ঢুকবো নাকি? Again, the today's topic is vertical motion because we will complete with vertical motion today. Now, once the particle is moving in the vertical direction, let the particle moving with u speed in the upward direction. So we know that the time of ascent should be equal to time of descent, and these two times are equal, and that is equal to u by g. So total time of flight, that is capital T, equals to 2 u by g. And another important point is that the maximum height attained by the particle. If I project a particle from point A, the particle will go up to point B. So AB distance is nothing but the maximum height, that is h, and that is equal to u square by 2b. These are the two basic formula that you have to remember. And another important point is that when the particle is moving downward, okay, let us say the particle is released from rest. Released means u equals to 0. And if I allow the particle to release from rest from a certain height, so let us say at height A, so vertically once the particle is falling down, so once the particle is reaching on the ground, it will hit with a velocity v. So what is the velocity of v? So for that, if I apply v square equals to u square plus 2g formula, okay. So v square is v square, u square is 0, g is negative, and h is also negative. So this is positive. Okay. So v becomes under root 4. That is another important relation. So once the particle is moving downward from a height h, and if it is released from 0, released from the initial position where the particle is at rest. Now the particle will hit the ground with a velocity of v that equals to under root 2. But that value of v is only useful when we assume that g number is constant, because here we assume g is constant. Okay, when the acceleration due to gravity is constant, then only I can apply this. Let us say once the rain is falling from a certain height. Let us say the cloud is formed at a height of, let us say, from the ground at a height of 5 km above. Okay, so at a distance of 5 km above, the rain cloud is being formed, and from that the raindrops are coming down. Okay, if the raindrops are released from rest, if I say e equals to 0, then the velocity of the raindrop once it hitting the ground, let us say v, that should be equal to under 2gh again. So if I calculate that number, 2g means 10, and h is 5 km means 5 into 10 to the power 3 meter. So ultimately I am getting 5 into 2 means 10. So 10 into 10 means 10 square into 10 to the power 3 means 10 to the power 5 under root. So that means 10 square into root 10 means root 10 means 3.33. So ultimately I am getting 333 meter per second. So this is the velocity with which the raindrop should strike the ground. But if the rain is assumed to start hitting the ground with that high amount of speed, then it will penetrate our head. Okay, it will penetrate our head. Why? Because the bullet that is coming out from a gun, if I fire a bullet, so maximum speed of the bullet is around 250 meter per second. Okay, and I am getting the raindrop velocity is 333 meter per second. That means something happening in between, so that this much amount of increase of velocity is not possible. Okay, so raindrops are falling gently on the ground, and the velocity is around 2 meter per second or 3 meter per second, not more than that. Okay, so it cannot be at this such high number. So that means something is happening in between the cloud and the ground. What is that? So that is the air. So now today's topic is the air resistance. So that means whenever the raindrop is falling vertically downward, so air present in the medium is offering a kind of resistive force. Because of this resistive force, the particle is slowing down. So ultimately, the particle will not get any kind of acceleration. One point will come when the acceleration becomes 0. Okay, and after that, the particle is moving with constant speed. So the constant speed with which the particle is coming down or the raindrop is coming down is known as the terminal speed. So for any free falling object, so it should attain a terminal speed. That means it is the maximum value of the speed that is possible. If I allow the particle to free fall, so ultimately one point will come. So ultimately, because of the air resistance, the velocity will be reduced ultimately, and at that particular point, acceleration becomes 0. So no further acceleration possible. But initially, what we assume that throughout From point A to point B, the acceleration due to gravity is acting downward and the particle is falling continuously with that acceleration g, and for that reason only I am getting this high amount of velocity. But that high amount of velocity is not possible. So there must be some kind of air resistance. We cannot neglect that. If the surrounding medium is filled with air, so air has to apply some kind of resistance. I cannot neglect that. If air is there, that means it is providing some kind of resistance, and because of that, the particle is not getting that high amount of velocity. Let us say the cloud is formed over here. Let us say cloud is formed over here, and the raindrops are starts to fall. So let us say the mass of the raindrop is m, a very tiny little mass. So once it is moving downward, it moves under the action of the gravity. So let us say the rain from drop starts at the point A, and gradually it goes to a point B. Between A to B, what is happening? Between A to B, air resistance is there, but the weight of the raindrop mg is acting downward and r is acting up. Now regarding the air resistance, r is called the air resistance. Air resistance. Now regarding the air resistance is a force which is proportional to the velocity of the particle. And r is basically proportional to v. That means I can say r is equal to some constant into velocity. So as the velocity of the particle is increasing, so gradually the r will increase. So at point A, once the particle is released from point A, at point A, the resistance due to air is 0. Why? Because at this point, v is 0. The particle has no velocity, so r is 0. So once the particle is moving downward, so from A to B, velocity is going to increase. Okay. So at point B, let us say V assumed such a value such that let us say equals to K V naught, and correspondingly downward force is mg that is fixed. And if at this point, if at B, mg equals to K V naught, that means net force is balanced and no further acceleration is possible. No further acceleration is possible. Okay. And that velocity V naught, that is equals to how much? Mg by K is assumed to be constant. Why? Because for the air, the K number is one constant. K is constant. If K is constant, then V naught is also going to be constant. That V naught value is known as the terminal speed. This is known as the terminal speed. So this is the speed. Terminal speed. It is the maximum. Kটা কোনো নাম নেই বাবা, kটা proportionally constant হবে। হ্যাঁ, value is there, value must be there, but that value has to be obtained experimentally. K value has to be obtained from experiment. So experiment will give a kind of value of K, because if I consider there is no storm, in a stormy weather condition, the K is on the higher side. If there is no storm, wind is blowing at a gentle speed, then the K value will be less. So it depends on the weather condition. If the weather is very windy, then the K value is on the higher side. If the weather is less windy, almost a humid condition, then the K will be somewhat different. So from experiment, you have to obtain the value of K, and you ensure that R number, that is the resistance due to air, is proportional to K. So initially there is no R. When the particle starts to fall, there is no R. Gradually, it will attain a certain velocity, and beyond which the particle is moving with constant speed, that is from B to C. So B to C, C is the point where the particle is landing on the ground. So between B to C, there is no further increase in the speed. Why? Because the particle is moving with constant speed. Okay. So the constant speed attained by the particle is known as the terminal speed. Now my objective is to calculate what is the velocity of the particle between A to B. Okay. So that means between A to B, velocity is a function of time. Okay. I want to calculate the velocity as a function of time between A to B. Between A to B, the velocity is changing. At point A, velocity is 0. At point B, velocity is B naught. Okay. So between A to B, there is a change in velocity, and now my intention is to calculate how the velocity is changing. Okay. How the velocity is changing. So for that, what we should do, let us say this is the point A, where the particle is initially at rest. So from point A to point B, the particle is moving. Let us say this is the point B. Okay, where I say the velocity attained by the particle is V naught. And I know what is V naught, that V naught equals to mg by k number. That number is also known to us. So I want to calculate what is the velocity at any intermediate time. Let us say at any time t, the particle is over here and moving downward with the velocity v. Okay, and for that situation, the resistance force is k times v, and the mg is acting downward, net force acting downward. Now at this point at any time t, if I observe the particle has a downward velocity v, and downward force is mg and upward force is kv. So at this particular point, can I say the net force acting along this direction F net is equals to mg minus kv? Why? Mg is downward, kv is upward. So corresponding to this, if I apply the net force equals to mass into acceleration formula, that is the Newton's second law. So can I write acceleration of the raindrop is equals to mg minus kv by m, or I can write g minus k by m into v. So this is the acceleration at any time t, which is a function of v. Okay, and I know that a, if it is a function of v, can also be written as dv dt. Now, dv dt is the rate of change of velocity, that is equal to acceleration, that is equal to g minus k by m v. So dv dt, that is equals to g minus k by m into v. This is the final formula. So now I have to integrate it. So dv divided by g minus k by m into v should be equals to dt. This is the final formula. Now in order to integrate it, let us say I am saying substituting this number as, let us say, z. I am saying the denominator number is z. So if I differentiate both sides, so I am getting minus k by m into dv should be equals to dz. Okay. Now once I do the integration, so our integration is integration of dv divided by z now. That should be equals to dv means what? dv means minus dz by k by m into z. So ultimately what I am getting? Minus m by k dz by z integration. Okay, minus m by k dz by z. So dz by z integration is how much? ln z. So from the left hand side I am getting minus m by k into ln log base e into z, and that should be equals to how much? On the right hand side, simply integration of dt is there. So that gives t. Okay. So if I put the limit, so let us say at t equals to 0, z value, z is what? Z is basically given by the number z equals to g minus a by m into v. So at t equals to 0, what is v? V equals to 0. So v equals to 0 means z equals to how much? Simply g number. At t equals to t, at any time t, let us say z is equals to g minus k by m into v. That is z. So ultimately I am getting minus m by k, if I put the limit, ln z by g, that should be equals to t number, or ln z by g equals to how much? Minus kt by m, or z by g equals to how much? E to the power minus kt by m. Okay, so this is the final format of the z. So I want to calculate the z number. So z is how much? Z is basically z equals to g minus k by m into v. That number should be equals to g times e to the power minus kt by m. Now you slightly change the sign and arrange the term. So if I take g common, so that should be equals to 1 minus e to the power minus kt by m. That should be equals to k by m into v, or v can be written as mg by k into 1 minus e to the power minus kt by m. So that will give the variation of the velocity v between the point A and B. My intention is to write this equation. So once I write this equation, now I want to plot this variation. So it is a variation which is exponential in nature. Why? E to the power function is coming in. It is the exponential function. So once I plot this variation, let us say I am plotting on the y-axis plotting v, on the x-axis plotting t. So at t equals 0, e to the power 0 means 1. E to the power something means 1. So at t equals to 0, e to the power 0 means 1. So 1 minus 1 equals to 0 means v equals to 0. Why? Because the particle starts from this. So graph will start from here. So as the time increases, it will go exponential. After some point of time, it curve becomes flat. Curve becomes flat. So once it becomes flat, that means I can say the particle will attain the terminal speed. So this value is terminal speed. Mathematically, this terminal speed has to be obtained when t is tending to infinity. Okay, t is tending to infinity. This v should be equal to v naught. If I put e to the power minus kt by m, e to the power minus kt by m for t tending to infinity. So it becomes e to the power minus infinity. E to the power minus infinity is 1 by e to the power infinity, that means 0. Okay, so exponential term becomes 0. So 1 minus 0 is 1. That is v naught becomes mg by k. That is the number that we have got. So we have initially got that v naught number is the terminal speed, that must be equal to mg by k. Why? Because at this point, at point B, what I am saying that v naught number should be equal to mg by k. Why? Because now the resistive force and the vertical downward force mg are balancing each other. So at point B, where the particle becomes constant speed, so that point is the point of achieving the terminal speed. So from point A, the particle moving downward, gradually the velocity will increase, and ultimately at point B, velocity becomes constant. Now with this constant speed, the raindrop will fall gradually. So there is no further increment in the speed number. So if I calculate this number, V naught number, because for raindrop mass is known, K is known for the exponential value. Okay, so once I calculate this mg by k number, I can get around 1 meter per second or 2 meter per second. More than that is not possible. Why? Because if raindrop are supposed to come with a very high speed, then it will be very risky to go outside during the rainy condition. Okay, why? Because if raindrops are coming with a bullet speed, the speed of bullet, then it will penetrate my head. Okay, and eventually সেটাই তো বললাম, সেই কারণেই তো বললাম টাইমিং অ্যাটেন্ড করছি। এতক্ষণ ধরে যে একটা কথাতেই বারবার হিট করে যাচ্ছে, সেটা একটু বোঝার চেষ্টা করছে কেন এই কনসেপ্টে ধোকা হচ্ছে। Because without air resistance, any particle cannot fall. If I neglect the concept of air resistance, then the particle will attain a velocity of around 333 meter per second, which is impractical. না, ওটা কখনো প্র্যাকটিক্যাল নয়। So since that is not practical, that means I have to select another condition. What is that situation? That situation is that the air resistance must be there. Without air resistance, the particle cannot fall. Okay. So this is the segment that I want to discuss. Now come to the another concept of particle motion, where I have to plot the variation in the graph. So now we go inside the kinematic graph. Graph means the variation, how the parameters are changing. So far we understand that. So in a kinematics problem, there are 5 different parameters that we have to measure. I have to measure the velocity, I have to measure the acceleration, I have to measure the displacement, I have to measure the time, and along with that, I have to measure also the distance term. Okay, so these are the different variables that I have to measure. Now, once I measure this variation or variables, now I have to plot the graph. That means how this variation takes place with respect to one. So these are the 3 important graphs that we have to do in this particular segment. One graph is the displacement or x versus t diagram, displacement versus time diagram. One is the v versus t diagram, velocity versus time diagram. Another is the acceleration versus time. So initially we will solve this type of diagram based on the condition that we assume that a equals to constant, acceleration is constant. Once a equals to constant, that means we are left with only 2 different equations. One equation is to plot the v equals to u plus at line. Another is to plot the s equals to or x equals to ut plus half. Okay, so these are the 2 graphs that you have to plot initially. Once I get the knowledge of these 2 graphs, then you can go for the situation where the acceleration is right. Okay, so initially there are 3 graphs. One is the xt diagram, and the vt diagram, and the at diagram. So for xt diagram, if I want to calculate the slope, the slope means dy dx, that is dx dt. So what dx dt gives? It gives the instantaneous velocity. If I calculate the area, that means integration of y dx, that is x dt. Here the y is x and x is t. Okay, so integration of y dx gives the area constant, and the integration will give the area, and derivative of that same function will give the slope. So if I calculate the area, that means integration of y dx, that has no information. So we don't have any information from this graph of area. Now come to the V versus T diagram. So for V versus T diagram, if I calculate the slope, it is dVdt, that gives instantaneous acceleration. If I calculate the area, that gives integration of V dt, that gives displacement. Okay, so both are important for the VT diagram. So that's why VT diagram is the most important information. So if I know the VT diagram, then from that VT diagram, I can calculate the slope and I can know the value of area. So from the slope and the area, I got two different information. One is for the acceleration and for the displacement. Now the third diagram is the AT diagram. So for AT diagram, if I calculate the slope gives the dAdt number that is known as the jerk. What is jerk? Jerk is a certain acceleration. If the particle is there, let us say I hit it with a stick. So I put an impulsive force, impulse means a large force for a very short duration of time. I hit it. Once I hit it with a stick, then it is certain acceleration. Initially there is no acceleration, but after some time, in delta t time, very small time, 0.001 second, it has some kind of acceleration. If that is the situation, then it is called a jerk. And the area, that is integration ADT, will give the V final minus V initial, that is a change in velocity, delta V. Okay, so these are the three diagrams, and the importance of the three diagrams is the most important is the number 2, then number 1, then number 3. Why? Because number 3 is least important, because now we calculate the situation where the acceleration is constant. If acceleration is constant, then AT diagram has no information. It is a constant line. Okay. So we prefer to go for the VT diagram first, then HT diagram, then you go for the AT. So first you try to draw the VT diagram. So this is the equation that you have to plot it. That is V equals to U plus AT, and that is representation of a simple straight line. So for any general straight line written in the form of Y equals to mx plus c, any general straight line can be written in the form of Y equals to mx plus c. What is it? M is basically the slope number, and c is the called y-intercept. Y-intercept. That means the position where the graph will intersect the y-axis. It's called the y-intercept. Okay. So that c number may be positive, may be negative, may be zero. That m number may be positive, may be negative, may be zero. All are possible. So initially what I am saying, if I compare these equations with this V equals to U plus T equation, now V is basically our Y number. V is basically our Y number, and T is basically our X number. So if I compare with the equation Y equals to mx plus c, so m is nothing but the acceleration. The slope of the VT diagram will give the acceleration, and y-intercept will give the initial speed. Okay, so this number is basically the initial speed, that is the c number, and a number is nothing but our slope of the diagram, that is a. Okay, now depending on the sign convention, regarding the sign convention, one must be very sure that for a straight line motion, when the particle is moving along the positive x or negative x, every time I will take the positive direction of the x as a positive. So this is the positive side of the axis, and that is the negative side of the axis. Okay, so this is the convention that we every time follow. If the particle is projected from point A, so that V0 is towards right and A is also towards right. And then both V0 is positive, A is positive. That is what I can say, that C number and M number both are positive. If C number and M number both are positive, then the VT diagram will be like this. Okay, so this is called the y-intercept. That number is the U number, or in our equation, this is V0 number. And the slope is basically this angle, this is tan theta. So tan theta is constant number, that is equals to M, that is basically acceleration. So if the particle is moving towards right with the velocity V0 and A, that means that gradually with time the velocity of the particle will increase. Okay, after time t, let us say the particle is, if at this time the velocity will be there. So this velocity is certainly greater than the V0 initial velocity. Okay. In the second situation, the V0 is negative, A is positive. So V0 represents the y-intercept. So that means the y-intercept has to be drawn to the negative. So this is the minus V0 number, and A is positive. That means the diagram should be like this. So upward line is basically the A positive, acceleration positive. Now what is the physical significance of this diagram? So in this situation, the particle is moving towards left, because whenever the velocity information and acceleration information at the starting point A is given, velocity information and the acceleration information at the starting point A is given. So depending on the direction of the movement, what is the conclusion? So conclusion should be such that the direction in which the velocity is given, at that direction the particle moves. Okay, that is here the particle is moving toward the negative direction. Why? Because V naught is negative. So particle moving in this direction. So gradually the velocity will decrease. Why? Because for this particle acceleration is toward positive direction. So once the particle moving toward left, so gradually the velocity becomes zero. So ultimately one point will come when the velocity becomes zero. Because from A to B, the velocity is going to reach. Because the particle is returning. And after point B, the particle will U-turn and move in the same direction. In this direction. Okay. So this is the representation by this diagram. So initially V naught is negative number. With time there is one point when the velocity becomes zero. So this is the point from where the particle is turning back. After the turning back, the particle has got the velocity in the positive. So V is initially negative and beyond this point it becomes positive number. Okay. So this is the case B situation and this is the case A situation. Okay. So either can particle move towards right or towards left with the turning back situation. Particle moving towards left and the velocity is such that ultimately one point will come when it becomes zero, and from that 0 point the particle is again moving towards the right side. There are another two situations C and D. In situation C, V is positive but A is negative. So that means particle is moving towards the V naught direction. So particle is moving in this direction. So ultimately one point will come when the particle velocity becomes zero. Why? Because as the particle is moving from A to B, the velocity is going to reduce because acceleration is in the opposite direction. Acceleration in the opposite direction means the velocity has to be reduced. So ultimately one point will come when the velocity becomes zero, and from that point onward again the particle will turn back. Okay, so case C is the example of the turning back, but initially the V naught is positive. Y intercept positive, but acceleration negative and the slope is down. So this is the diagram. So if the acceleration is positive, draw a upward line, straight line. If the acceleration is negative, draw a vertically downward slope direction line. Why? Because in this situation the acceleration becomes negative. So again I am getting the information that at this point the velocity becomes zero, that means particle is turning back from this. So once the particle turns back, from V point onward, particle is moving towards left, that means in this direction the velocity is negative. Okay, velocity is negative. So last situation is the case D, where both are negative. Both are negative. So both are negative means start the diagram for this negative side, Y naught, V naught, and A is negative means move downward direction. Okay, so this is the situation D. Now from these two situations, I can now get the information about the vertical motion. So in a vertical motion, if I say the particle is projected upward with a velocity of V naught. Okay, so I say that whenever the particle is projected at a particular point, so I take the upward is positive and acceleration due to gravity is G downward. So V is positive, G is downward or negative. That is the situation number C. So this is the situation where the particle is projected upward. Okay, V is positive, G is negative. That is the case number C. And if I say at a certain from a certain height H, I released a particle. So particle moving downward with a speed V naught and acceleration with gravity is also G downward. So that means both are negative. So once the particle is falling from a certain height, that is resembles to our case number D. So this is the case number D. So when the particle is falling vertically downward, so when the particle is falling vertically downward, so this is the diagram. Okay, when the particle is moving up, then going down, then option number C. Okay, so this is how I can relate all the four diagrams together so that I can get the idea how the behavior of the velocity with respect to time is. Now, another situation is there if the V naught number is 0. If the V naught number is 0, V naught means what? U number. U means C intercept. So if C becomes 0, then all the diagrams should pass to the origin. So for the first situation, this should be the diagram. For the second situation, this should be the diagram. This should be the diagram. For the third situation, this is the diagram. And this one is the diagram. Okay. So if V naught is 0, then all the diagram should start from the origin. Why? Because y intersect is 0. That's all. This is for the V versus T diagram. Okay. Now moving on to the next diagram where I say this half it is to this diagram. So it is nothing but a parabolic equation. The parabola is a 2D diagram. So parabola has two types of variation. In the first segment, I see that there are four types of variation. Here there are only two possibilities. Either the parabola may be upward facing, upward facing parabola may be this type. Okay. Or parabola may be downward facing. Okay. So for upward facing, the acceleration has to be positive. A is positive. So when the A is positive number, then it is upward. When A is downward, means acceleration negative. So for this first situation, V is positive, V naught is positive, A is also positive. Then the upward facing parabola. Here V naught is negative, but A is again positive. It is also upward facing parabola. So both case A and case B will give upward facing parabola when I plot displacement versus time diagram. Okay. So if I plot the displacement versus time diagram, so this is not V, this is displacement S versus T diagram. So for the first situation, it should be upward. Now, in order to plot the diagram correctly, know that velocity is positive over here. Okay. So velocity V naught is positive means you have to draw the diagram in such a way so that at t equals to 0, there must be one slope that is upward, like this. If I draw a tangent at t equals to 0, so that basically gives the value of ds dt number, and that is the velocity of V naught. I cannot say here it is 0. Here it is 0. So this is the case A. Now for case B, I know that the particle is moving in this direction, and ultimately particle will turn back in this direction. Okay. So velocity is negative and parabola is upward facing. So parabola upward facing, velocity is negative means the diagram should be like this. Okay. So there is one point when the particle comes back to the initial position. Let us say the particle starts from point A, it moves up to point B, from where it turns back, again it will crossing the point A again. Okay. So point A cross again means at that particular point displacement is 0. So this is that particular point where the displacement is equal to 0. Okay. So at this point the particle is again crossing the point. So entire diagram should be down upward facing parabola because throughout this acceleration is positive. So either acceleration is positive or acceleration is negative. Depending on that, there are two types of parabola. First we discuss about the upward facing parabola, then we discuss about the downward facing parabola. So here A is negative, here A is negative, here also A is negative. So both are basically downward facing parabola. But in case C, what is happening? The particle is turning. It goes from A, then comes to point B, where the velocity of the particle becomes 0. Then from here it comes back in this direction. So whenever there is a situation where the particle turns back, you have to be very careful, because at that particular point, velocity, there is one point where the velocity becomes 0. So there is one point B where the velocity becomes 0. So if I plot a downward facing parabola, if I have to plot a downward facing parabola such that at point B velocity becomes 0. And how to locate the velocity for the S versus T diagram? That means slope. If I take ds dt number, that gives the velocity information. So ds dt will be 0 at point B, from where the particle is turning back. So I have to draw a downward facing parabola like this way, and there is one point where the slope becomes horizontal. So this is the point B where the ds dt becomes 0. Now from point B onward, again the particle is throughout downward facing, but there is one point when it crosses the A point. That means at this point is x number, not the v. At this point x is 0. Now further going down. Okay. So this is the variation of x versus t for a situation where the particle in a vertical situation, if I throw a particle in this direction, the particle will go up to this point, then again come back. So this is the situation where I draw this type of parabola. Okay. So the x versus t diagram. And ultimately there is another situation where the particle is moving left, acceleration is also left, means throughout downward facing parabola, and entire parabola should be in the third quadrant or fourth quadrant. Okay. So this is downward facing parabola. Okay. So only thing is that you have to be very careful about plotting this kind of diagram. Why? Because in plotting this type of diagram, you have to ensure, you have to know there are the certain point where the velocity may be zero or the acceleration may be zero, anything may be there. In this situation, if I say the acceleration is zero, particle is moving with zero acceleration. That means S equal to Vt only. That means the line should be a straight line. Okay. So the particle may move with some acceleration, may not. So once the particle is not moving with acceleration, then the velocity is not changing, that is constant. Okay. This is the Vt diagram. Vt diagram is given. So Vt diagram, first part of the diagram from A to B is a straight line. That means straight line upward means particle moving with some acceleration is there. So it is acceleration. Then B to C, Vt diagram is straight line and it is parallel to the t-axis. That means acceleration is zero. Means particle moving constant speed. Then again C to D, line is downward. That means negative acceleration. Retardation. So for A to B path, it should be upward facing parallel. For B to C to be a straight line, C to D to be a downward facing parallel. Why? Because XC diagram for acceleration is upward facing parabola, for retardation is downward facing parabola, and for constant acceleration, XC diagram will be a straight line. So first we draw the constant acceleration part. So here the particle moving with upward facing parabola, but you will draw the diagram in such a way so that the slope will be zero at this point. Why? Because the particle starts with initially at rest. Okay, so there is no y-intercept, means you will draw the diagram like this way, touching the t-axis like this. Okay, so that it will imply that it is slope is 0 at t equals to 0. Now from this point onward, the particle moving with constant zero acceleration. That means it should be a straight line like this. Okay. Now once I move up to this point, now the next part is retardation. So downward facing parabola, but you have to be careful that at point D, again the velocity is zero. Again the velocity is zero. So that means at point D also slope must be zero. You will draw a downward facing parabola from this point such that the slope will be zero at this point. So this is a zero. So this is the parabolic curve, this is the parabolic curve, this is the straight line. Okay. So this will give the value of x versus t diagram. Okay. Similarly, there are other situations also. Let us say come to this problem. Okay. So particle starts from rest. Its acceleration versus time diagram is shown in the figure. So initially the velocity is 0. Acceleration starts from rest means u number is 0. Initial velocity is 0. A versus t diagram. So it is a variable acceleration given as this one. Okay. So in variable acceleration, the area under the AT diagram gives what? The change in velocity. Let us say here the particle moving with v1, here the particle moving with v2 velocity. So v2 minus v1, that number is basically the area. Now what is area? It is the area of a triangle. So half base in 11 into 10 into 55. The 55 will give the value of change in velocity. Now change in velocity means velocity as 11 second, velocity as 11 second minus velocity as 0 second. That number is given as 55. Now velocity as 0 second is 0. So velocity as 11 second should be equal to 55 meter per second then. Okay. So answer will be 55 meter per second. Similarly, let us say this is the diagram. Okay. So V versus S diagram is. So these are the some uncommon diagram. Okay. So there is a V versus S diagram is given. So you are asked to calculate the acceleration of the particle at S equals to 2. Now, in a VS diagram, slope is what? If I want to calculate the slope of this diagram, slope is what? Slope is basically dvds. dvds. Now we know that acceleration is equals to how much? Acceleration is equals to v times dvds. Now what is dvds? So dvds number is a slope. Slope is vertical distance is 20 and horizontal distance 50, but with a negative sign because slope is negative. Okay. So it is minus 20 by 50. That is minus 2 by 5 is the slope. So you are asked to calculate the velocity or acceleration at s equals to 0. when the s equals to 0, at this point v equals to 20. Okay, at this point v equals to 20. So acceleration equals to minus 20 into dv dx is 2 by 5. So minus 8 meter per second square. Okay, not it will be plus 8, it should be minus 8. Option number B. Okay, so you have to be careful about the sign. So if the slope is coming to be negative, take that slope. If the slope is positive, then take the positive value of the slope. And depending on that, you will get the answer for the acceleration. Similarly, this is another situation where the diagram is given as versus v square versus s. Earlier one was v versus s, now it is v square versus s. Now we are asked to calculate again the acceleration of the particle once the particle is at s equal to 0. So for this situation, what is the slope then? Slope should be equal to dy dx. Now, dy dx. Now what is dy? d of v square ds. That means 2v dv ds. So that means it is equal to 2 times of acceleration, because v dv ds is our acceleration. So this 2 times the acceleration equals to our slope. Now what is slope? Again slope is 20 by 50 but with a negative sign. So minus 20 by 50 with a negative sign. So that is minus 2 by 5. So our acceleration should be equal to how much? Minus 1 by 5. It is minus 0.2 meter per second square. Option number B then. Okay. So the diagram may be v versus s, velocity versus displacement, or square of velocity versus displacement. Whatever the situation, we try to find out the slope. Once I calculate the slope, that means dv ds or v dv ds, these values are known to me. So depending on that, now I can calculate the acceleration. Okay. So let us say the velocity versus displacement diagram is given. Two particles moving along a straight line is given by this diagram. The most suitable a versus x diagram. You are asked to plot the a versus x diagram. So velocity versus x is given. So from that you want to calculate the a versus x. Now again, so this is a line which is a straight line. Okay, so this is a straight line. So for straight line, I have to know the equation. Let us say equation is y equals to mx plus c. Now what is m? M is the slope. Slope is how much? Vertical displacement by the horizontal displacement, but slope is negative. So that should be equal to v naught by x naught. Okay. Now what is x? X is x. And what is c? C is the y intercept, that is equal to v naught. And that is equal to y. Y is what? V. So this is the relation of v versus x. Okay. If I simplify it, it is minus v naught by x naught into x plus v naught. So this is the v versus x diagram. Okay. So in v versus x diagram, the slope represents the acceleration. So acceleration is constant. Now, what is that acceleration? This is the acceleration. So this is called the acceleration, which is equals to minus v naught by x naught. So that number is constant. Why? Because v naught and x naught both are constant now. V naught and x naught both are constant number. So acceleration is constant. It is not changing with respect to x, and also acceleration is negative. So it should be the diagram. It is the negative acceleration first of all, and constant. It is not changing. What is the answer? That is equal to v naught by x naught with a negative sign. So option number D will be your correct answer. V naught by x. Okay. So another variation is like this. Okay. So the another type of question may be like this. The plot of instantaneous square root of velocity, that means root of v. Root of v versus x diagram is given. Okay, which actually displacement is given. So you are asked to calculate the instantaneous acceleration at point A. So I know that instantaneous acceleration A is nothing but dv dt. Either I can write, or I can write v dv dx. Okay, v dv dx. But here, if I want to calculate the slope at point A, slope at point A, that is given as tan 37 in the diagram. So tan 37 is basically 3 by 4. The slope is 3 by 4. Now what is slope number? Slope is equals to dy dx. dy dx. Now what is y? Y is root of v dx. That means ddx of root v. That means ddx of root v means 1 by 2 root v into dv dx. Okay. So this is our slope number. But I have to calculate the acceleration. So what is the acceleration? Acceleration is equals to our V times dV dx. V times dV dx. So that number I have to calculate. But this slope is given as value as 3 by 4. So that means dV dx is how much? dV dx is equal to 6 root V by 4. 2 root V multiplied by 3 means 6 root V by 4 means 3 by 2 root V. That is the dV dx number. So corresponding to dV dx, now I can calculate the acceleration. What is the acceleration? So acceleration equals to V. V is V. dV dx is how much? 3 by 2 root V. That will be your answer. But from the diagram, I know that you are asked to calculate the dV dx or acceleration at this point. So at this point, root of V is 2. So this number is root of V. So root of V is 2. That is V equals to 4. So if you put this number over here, so 4 into 3 by 2, the root of V is 2. So ultimately 12 meter per second square. So 12 meter per second square will be the instantaneous acceleration at point A once the slope is descending. Okay. So there are different types of variation in the diagram. Okay. So depending on the variation given, you have to be write the slope at that particular point to calculate either acceleration or velocity depending on the situation. Okay. In a car race, car 1, red car. Let's say this is car number 1 and there is another car number 2. So two cars are racing with each other. So car 1 takes a time t second less than car 2. That means if say the car 1 process this racing at t naught time. Okay, so let us say car 1 takes a t naught time. So time taken by the car 2 should be how much? T naught plus t, because car 2 is taking more than t time. Okay, so car 1 is taking t less. That means car 2 is taking t more at the finish and passes the finishing point with a velocity v more than that of the car. Let us say car 2. Let us say the velocity of the car 1 crosses this point is v naught. Now, once the particle is crossing point 2 with a velocity v naught minus v, because car number 2 is finishing with a velocity, or car number 1 is passing the finishing point with a velocity v more than that of the car number 2. So car number 2, once it crosses, it should have a velocity then v naught minus v. Okay, so these are the property of the car number 2 and these are the property of the car number 1. So car number 1 wins the race. That means it should take less amount of time and more amount of velocity. And it is also given that both the cars starts from rest. Initially both are having huge and they travel with constant acceleration a1 and a2. Now you have to calculate you have to show that relation between v, a1, a2 is this. Okay. So both are covering the same distance. Both are covering the same distance. Let us say that d is the distance between the initial point and the final point. Let us say this is the d distance. So for car number 1, if I apply the formula for the car number 1, so for car number 1, this equals to, if I say d equals to ut plus half at square. So this formula. So d should be equal to u will be half a1 into t naught square, because car number 1 is taking t naught time. And for car number 1 again, v equals to u plus at means v naught should be equals to a1 into t naught. So these are the two equations for the car number 1. Similarly, for the car number 2, I can write another set of equations. For car number 2, if I write d number, so d should be equal to ut plus half at square. So d should be half a2 into t should be equal to t naught plus t whole square. Okay, and final velocity v naught minus v should be equals to a2 into t naught plus t. Now you have to get a relation between v, t, a1, a2. But I have taken some more unknown, that is one is d, another is t naught. So I have to replace those d and t naught. Okay. So for that, if I equate equation number 1 and equation number 2 for this, let us say I am giving the numbering. Let us say this is a and this is the equation number b. If I equate a and b, a equals to b. If I equate these two equations, so that means half a1 t naught square should be equal to half a2 into t naught plus t whole square. half cancels out. So I am left with T naught plus T by T naught whole square should be equals to A1 by A2. This number. Nah. T naught plus T whole square equals to. So T naught plus T by T naught, that number equals to root of A1 by A2. Or 1 plus T by T naught, that number is equals to root of A1 by A2. From that I can calculate the value of T by T naught, that should be equals to 1 minus root of A1 by A2. Or from this equation I can write the value of T naught. What is T naught? T naught should be equals to T divided by 1 minus root of A1 by A2. Okay, so these are small T naught that we have taken in the time to cross the race by card number 1. Okay, now again, if I subtract these two numbers, let us say this is the equation number C and this is the equation number D. If I C minus D from the left hand side to V naught minus V naught, that should be equals to A2 into T naught plus T minus A1 into T naught. Now, left hand side becomes how much? Left hand side becomes minus B. That should be equals to, if I take T naught common, so T naught into A2 minus A1 plus A2 times T. A2 times T. Okay. So this is the final equation. So here we put the value of T naught. So I got this T naught, this number, if I substitute this, so it gives T divided by root of A2 minus A1, root of A2 minus root of A1, and here is root of A2 multiplied by A2 minus A1 plus A2 into T, this number. Okay, so if I simplify it, A2 minus A1 can be written as root of A2 plus A1 into root of A2 minus A1. Okay, so root of A2 minus A1 cancels out, ultimately we are left with root A2 plus A1. So I am getting root A2 into root of A2 plus root of A1 into T plus A2T. So if I add this, so I am getting A2T plus root of A1 A2T, not plus, it should be minus. This number is minus A1T. No, minus. So ultimately minus, so here is also minus. So this A2T and A2T will cancel with the root of A1 A2T. So ultimately what I am getting, D should be equal to root of A1 A2T. Okay, because negative sign cancels out. So there is one negative sign. So D and negative will cancel out. So we are left with D equals to under root A1 A2 into A2. Okay, so this is the problem. So in this equation there are two cards. So card number 1 is taking T less than the card number 2. So that means if the card number 1 is taking T naught time, card number 2 will take T naught plus T time. Card number 1 crossing with a high speed. If card number 1 is speed is V naught, the second car has a speed of V naught minus V. So I write 4 different equations for card number 1 and card number 2. V equals to U plus AT, V equals to U plus AT, S equals to U plus W square. But for all those cards, they are starting with rates, so these are the equations. So ultimately what I am doing, basically I am calculating the equating A and D, 1 and 2. Equating equation number A and equation number B, I got one relation of T naught, and with that T naught, if I subtract C from D, so V naught minus V naught, so ultimately we got minus V, and if I simplify this, ultimately I am getting. Okay. So this is the answer.